So coming to the first problem, the figure shows an auto transformer used to supply a load of 2 kilowatts. So the output power is 2 kilowatts. So V2 I2 cos phi 2. This is called the P2. At the terminal voltage is V2 is 230 volts. As V2 is 230 volts from a 400 volts AC supply. As 400 volts AC supply. Find the currents in parts AC. Yes, what is the current which is flowing in AC section, and what is the current which is flowing in a BC section. And this is I2, and this one is I2 minus I1, and it is a step down auto transformer. Neglecting the losses and no load current. Also find the copper saving due to the use of auto transformer instead of using 2 winding transformer. Assume purely resistive load. So this is 2000 is equal to V2 is 230, and what is I2? So I2 we have to calculate, and the power factor of the load is 1. Why? Because he is given as a purely resistive load. So 2000 divided by 230, then the current I2 I can get it as 8.69 amperes. So what is the transformation ratio of the auto transformer, where K is equal to I1 divided by I2, and the K we can calculate it as V2 by V1 also. That is 230 divided by 400 volts. 230 divided by 400, so that is 0.575 as the transformation ratio. If you know the from this 0.575 is equal to I1 divided by 8.69 into 8.69, then I got it as I1 is approximately equal to 5 amperes. And as the current which is flowing in an AC section is 5 amperes, and here the load current is 8.69 amperes. Then you can calculate the current in BC section. As current in AC section as I1, that should be equal to 5 amperes, and the current in BC section is equal to I2 minus I1, that is I2 is 8.69 minus 5, that should be equal to 3.69 amperes. And after that he is asking find the copper saving. So how the copper is saved? So saving of copper is equal to K into weight of the 2 winding transformer. The K I got it as 0.575 into weight of the 2 winding transformer. That should be equal to 57.5% of weight of the 2 winding transformer. And coming to the next problem, a 10 kVA 230 volts by 110 volts transformer, that is 2 winding transformer. So 230 volts 110 volts transformer is used as an auto transformer. What will be the voltage ratio and output rating of an auto transformer? So this is a 2 winding transformer, can be used like this. So we can use 230 plus 110 volts series aiding we are using, that should be equal to 340 volts, and these 2 windings are electrically connected. The output voltage is now it is 110 volts. The input voltage is changed to 340, and the output voltage is same is 110 volts. And for the 2 winding transformers, you should, what is the kVA rating of 2 winding transformer is 10 kVA, and the current through 230 volts winding is equal to 10 into 10 to the power of 3 divided by 230, so that should be equal to 43.5 2.478 amperes, and this is a current which is flowing through 230 I1, and the current through 110 volts winding is equal to 10 into 10 to the power of 3 divided by 110, that should be equal to 90.909 amperes. So now the input voltage is changes to 230 plus 110 is 340, and this is 110. Now this one is 230 volts. The current which is flowing through 230 is directly, I am writing directly 43.478 amperes, and the current which is flowing through this one is I2, and now this is I2 minus I1. So let us calculate the transformation ratio for the auto transformer. So this is for auto transformer. So 110 divided by 340, 0.3235, and the K is equal to I1 divided by I2, and 43.478 divided by I2, and now I2 is equal to 43.478, the K value, so we are calculating 0.3235, that should be equal to 134.386 amperes. So this is 134.386 amperes. So I2 minus I1, obviously you will get 90.909. The current which is flowing through 110 volts winding is 90.09, and if you apply the KCL at this point also, you will get I2 is 134.386 amperes. Then the output rating is equal to V2 into I2. So what is a V2 is 110 into 134.386, that should be equal to 14.782 kVA. So observe this, 10 kVA 2 winding transformer is connected as an auto transformer, then the kVA rating is improved by 4.782 for this problem kVA. And coming to the next problem, this is a very important problem, and this is repeated in so many times. A 2200 by 220 volts 20 kVA 2 winding transformer is connected as an auto transformer to transform 2200 to 2420 volts, means is connecting as a step up auto transformer. Find the transformation ratio. Yes, what is the K value, what is the kVA rating of an auto transformer, and what is the currents which are in a transformer, and the efficiency at full load at 0.8 power factor if the core loss is 150 and full load copper loss is 275, right? So this is 2200 volts by 220 volts, 2 winding transformer. The rating is also 20 kVA. This can be connected as an auto transformer. So this input voltage is 2200 volts, and the output is now 2420 volts, and the current now it is I1, and this one is I2. Okay, now this is I1 minus I2. So calculate the current in each winding. Current in 2200 volts winding is equal to 20 into 10 to the power of 3, 20 kVA divided by 2200. So that should be equal to 9.091 amperes. The current in 220 volts winding is equal to 20 into 10 to the power of 3 divided by 220, that should be equal to 90.91 amperes. See, this is a 220 volts winding. Yes, this is a 2200 volts winding. Now the I1 minus I2, that should be equal to 9.091 amperes, and the current which is flowing in this winding 200, it is a shortcut method, that is I2 is equal to 90.91 ampere. Then I1 is equal to, as if you apply KCL at this point, 90.91 plus 9.091 is approximately equal to 100 amperes. So otherwise, if you have a doubt, first you should find out the transformation ratio V2 by V1. 2420 by 2200, that should be equal to 1.11. If K value is 1.11, we can say that it is a step up auto transformer. And what is the I2 value? The I2 value is 90.91. So why? Because I2 value is 90.91 amperes. So this is for auto transformer only. And the K is equal to I1 divided by I2. So I can calculate I1 is equal to K into I2. 90.91 into what is the I2 value? The I2 value is 90.91 and K is equal to 1.1. The K is equal to 1.1. That should be equal to 100.001 amperes. So check that. So directly I am writing, see here, I1 I got it as 100 amperes. So if I1 is known, I2 is known, can I calculate I1 minus I2? Yes, surely. So current through BC is equal to 100 minus 90.91, that should be equal to 9.091 amperes. And what is the fourth bit? I think kVA rating of an auto transformer. Yes, second bit, kVA rating of an auto transformer is equal to 1 by 1 minus K, where K is replaced with 1 by K, as I said, for the step up transformer, into kVA rating of 2 winding transformer. So this is K by K minus 1 into 20 kVA. K is 1.1 divided by 1.1 minus 1 into 20. So 1.1 by 0.1 into 20, that should be equal to 220 kVA. So the third part is also calculated, and coming to the fourth part, efficiency is calculated at a point per factor. So efficiency of auto transformer is equal to, so kVA rating of an auto transformer into 0.8 divided by kVA rating of an auto transformer into 0.8. So plus iron losses plus copper losses multiplied with 100. So 220 into 10 to the power of 3 into 0.8 divided by 220 into 10 to the power of 3 into 0.8 plus iron losses plus copper losses, that should be equal to 425. Why? Because iron loss is given as 150. So 150 plus 275, that should be equal to 425 watts into 100. Then I got the efficiency is 99.57759. So 759%, 759%. So if you want to calculate the efficiency of two winding transformer, the rating is 20 kVA. 20 into 10 to the power of 3 into 0.8 divided by 20 into 10 to the power of 3 into 0.8 plus 425 into 100. So by using calci, if you calculate, so what is the efficiency of a transformer, two winding transformer, when compared to auto transformer? So you can see now. So I am using calci. So 97.412%. So for an auto transformer efficiency is 99. For two winding transformer I am getting as 97.412. That means what are the points we discussed in the previous lecture? You can see efficiency is improved. KVA rating is also improved, and transformation ratio for the step up or step down is also changed. So saving of copper is also there. These are all the problems and the basic and most important problems we are discussed.